Now we move toward the exercise. The first question of the exercise is uh, in the first question the we will check that the series 2 over n square plus 3 n square plus 3 either this series is convergent or divergent. If the limit is 0, then of course it is very series convergent. Okay, the solution is limit n approaches to infinity 2 over n square plus 3 2 over n square plus 3. So this will be after applying the 2 over of course we can take common n square, which is equal to limit n approaches to infinity 2 over n common, and it is 1 plus 3 over n square. And when we apply the limit, and after now we are going to apply the limit, and after applying the limit here, this is 2 over infinity, we get the 2 over infinity form, which is equal to 0. 2 over infinity means 0. So this implies that series is convergent. The sequence converges to 0. Since sequence converges to 0, this implies that the series is convergent, implies series is convergent. Okay, now we move to the second question. In the next question, exercise 2. In the second exercise, the series is just like cos pi n, cos pi n, where n is 1 to infinity. Okay, and now we take the sequence an, which is equal to cos pi n. Cos pi n, and when we take the limit n approaches to infinity, n approaches to infinity of an, which is equal to limit n approaches to infinity of cos pi n, we get two values, plus minus 1, because for we get two values. The first value is 1. 1 is if n is even. If n is even, and the second value that we get is minus 1 if n is odd. N is odd. Okay, So these are two values. For n is even and for n is odd. This means that the limit is not unique. If a limit is not unique, then it means that the limit does not approach to 0. Means a limit n approaches to infinity, for limit n approaches to infinity, does not approach to uh, en the limit n approaches to infinity for what? N approaches to infinity of an. Okay, the limit of an okay limit n approaches n approaches to n approaches to n approaches to infinity of an is not equal to 0. This implies that series diverge. Series diverge. Okay. Now we move to another example, the second example. In the next example, exercise 3 is 1 over 2 plus x raised to the power 2 plus x raised to the power n, and x mod is less than 1. Okay, this series, if I expand this series will be of the form for n is equal to 1. This will be of the form for n is equal to 0, 0 to infinity, 1 plus 1 over 2 plus x and plus 1 over 2 plus x square plus up to so on. Okay, so this is of course geometric series with common ratio. Common ratio is r, which is equal to 1 over 2 plus x. This is the common ratio for the geometric series, and this common ratio for the convergence, it should be less than 1. If the series is convergent, then it should be less than 1. So now we check that either it is less than 1 or not. If it is less than 1, then the series will be convergent, and if the series is convergent, then we find the limit of the series for what value on which it is convergent. Okay, now if it is convergent, find the limit. Okay, it should be less than 1, because in geometric series a series is convergent if common ratio is less than 1. So 1 over 2 plus now it is given that since x, it is given that x prime mod is less than 1, and this implies that I can write it implies that x is in between greater than minus 1 and is less than 1. So if I multiply by adding 2, then we get 1 over here, because minus 1 plus 2, here it will be x plus 2. Okay, and here it will be of course we are adding 2, it will be 3 over here. Okay, and if we take the reciprocal, okay, take the reciprocal, then we can write, okay, oh sorry, what it happens, okay, now x, yes, by taking the reciprocal, after taking the reciprocal, it will be 1 over 3 is less than 1 over x plus 2, which is less than 1 over 3, 1 over 1, because we are taking the reciprocal. Yeah, 1 over 3. Okay, since it is, so it means that the common ratio, you can see over here, common ratio is less than 1. So it means that the given series which is geometric series is convergent. And since it is convergent, so we will find the uh, uh, you know, after applying the formula is since Sn is equal to 1 minus r, as this formula Sn is equal to 1 minus r raised to the power n divided by a into 1 minus r. Okay, so a is the first term, which is 1, and r is the common ratio, which is 1 over 2 plus x. So we will put over here. Okay, after putting the values over here and taking limit as n approaches to infinity, what is the problem? The page is not scrolling down. Okay, I know if I apply the formula, okay, the common ratio is 1 over 2 plus x. Okay, and apply the formula, and after applying the formula we will get just like it is Sn is equal to 1 minus 1 over 2 plus x raised to the power n divided by a into 1 minus r. 1 minus 1 over 2 plus x, and just after simplifying we get it just like 2 plus x into 1 plus x, and it is 1 minus 1 over 2 plus x raised to the power n. Okay, and after applying the limit, since it is Sn, limit n approaches to infinity, limit n approaches to infinity, 1 over 2 plus x raised to the power n, x raised to the power n, 2 plus x. Okay, this will converge to 0. Okay, so limit n approaches to infinity of Sn is equal to, after applying Okay, here since this term will get 0, this will be 0, so this means that our answer is 2 plus x divided by 1 plus x is our answer. Okay,